Assalamu alaikum, dear ABCDryBasin project participants. In the first video, we have finished our first training session, and now we will start our second training session for calculating the spectral indices and especially the NDVI, the normalized vegetation, the normalized difference vegetation index. At the end of the first training session, we visualized the data set in a true color image, and also we visualized the LST, the LST, which is the surface temperature band, and these are the results. This is the layers. We have the layer of the study area, which is the boundary of the study area only, and this one is the true color image of that of the code number or the line number 37, and this one here is the LST image for the study area, which is Yarmouk River Basin within the boundaries of Jordan, or the Jordanian part of Yarmouk River Basin. Now we will start our training session, the second training session for calculating the NDVI. In order to calculate the NDVI for a specific image, we need to use a reduce function. This reduce function can be, for example, the data set can be reduced to the mean or the median or the mode or the maximum, the minimum. So you can select the reducer as you want. By this way, for example, in our first training session, we got two elements, two images. Sometimes you may get 20, 30 images for your specific area or for your study area within the dates that you selected. For example, here in our first training session, we selected the images within January 2023. So if you have more than, let's say, more than 1 month, or let's say for the whole year, we should use a reducer in order to calculate the NDVI for that specific date. In this case, I'm using the mean function, the dot mean function actually, for the data set. So I named a new variable with the name dataset mean, which contains the data set from our first session, and then use that data set to calculate the mean value of the pixels within that data set. Then in line 55, I requested the GEE to print the data set mean and to name it in the console as data set mean in order to check its properties here. So we will see another layer. Once I hit run here, we will see another let's say another line says data set mean with its properties. For line 57 to 61, these lines are used to visualize the dataset that I want. For example, the dataset mean here, because the bands are, for example, the band 4, band 3, band 2, which is the true color image of this mean image. Map.add layer, and this will add the layer to the map view here, as we learned in our first session, using these properties for the visualization. And for example, here the false means please generate or create the data set, but don't draw it directly here. We will see it in the layers, but it will be unchecked. If you want to be to present it directly, you just delete the false word here. Print dataset mean and dataset mean. This means that it is the same one here. So if you want to stop it, for example, you just write down, type, let's say, the 2 backslashes here, 2 backslashes. Oh, sorry. 2 backslashes, and it will turn the code to a comment. In the second step, after defining the dataset or reducing the dataset, we want to compute the spectral index using dot expression function. and you can change the name or the variable of each let's say the selected band or the band of interest based on the index that you are calculating. For example, here I named it as var index, which is in any index or any name, let's say. Dataset mean, which is the dataset that I reduced in the previous step here, in step 1. And then dot expression, I want to use the expression, which is this one. This is the expression that I want to use, which is NIR minus R minus red divided by NIR plus red. These are variables. These are variables, and I have to define these variables. So, for example, here I defined the NIR as band number 5 in the dataset mean. This is the dataset mean that we generated in the first step. And in the second one, for example, here, the red is defined as band 4. So if you are calculating any other index, you just write down here the right expression for that index and then change the name of the variables here. After you generate or after you select the appropriate spectral bands, or let's say temperature bands, whatever you want to calculate, then you just write this one here, this small command, which says dot rename as NDVI. So after calculating the index, rename it as NDVI and add it to the bands of that image collection. So for example, here we have 7 bands already from the first session, and now we will find another band number 8 named as NDVI for each image in the data set. Print index and name it as this one here. So print will appear here in the console part, the index, and show it under this name. There is another example for using the expression that contains constant values, like, for example, the EBI. The EBI contains many bands, like this one, for example, a near infrared and the red. Also, we have the blue band, and also we have some constants here. So if you want to use such as index, you just type it within the expression and then define each variable in the index. The NIR, the red, the blue, select whatever the bands that represent the true band in the index. And after that, use the dot rename to rename it and create a new band to that dataset. You can also use the print command. It is optional, actually. Any print command is optional. Any print command is optional, but we usually add it in order to check, for example, the number of elements within that study area, or in order to check if the band that we are creating is created correctly. For this one, the palette, or let's say the plate, it represents a color composite or a color schema. It is optional to present the NDVI image or the whatever the index that you are creating. So it is optional, actually. For line 94, map.add layer, I want to add the index map for the NDVI, and I want to add also the index with constant image, which is the EVI image, to the map view here. If you would like to export the dataset or the results, the NDVI image or the EVI image, or for example, the LSC image, whatever the image that you want to export from the image collection, you use line 98. This one, export.image to drive. It will export your dataset or this image to your Google Drive, to your account, Google Drive, and after that, you can download it and use it, for example, with ArcGIS or QGIS or whatever the software that you are using. So in order to export the image, you should add these commands here. The image that you want to export, which is, for example, in this case, index. This index represents the NDVI, as you can see here. If you want to export this one, you just change the image that you want to export to this, to the name of the dataset that you want to export. So for like this one, for example, if you don't want to create another one with the same properties, you just change this one here. The description, this is the name of the output once you export it. And the scale, which is the scale of the image, we are using Landsat 8. So this is why I selected the 30 meters. It means 30 meters, which is the spatial resolution of Landsat. So if you are using, for example, Sentinel with 10 spatial resolution, you change the scale to 10 meters. The region, it is the table. The table means the study area. The study area. So these are compulsory. The image, the description, the scale, the image, the region, sorry. CRS means the coordinate system. So once you export it to Google Drive, it will export it using this coordinate system. This code is the code of the coordinate system, which is WGS 86 UTM zone 36 north, which is the coordinate system in Jordan. So if you would like to use it for your study area, you should find the code of your study area. For example, you can search it in Google in order to find the appropriate code for your study area. Let me just try it. For example, what is the code? For example, what is the code of UTM zone, let's say 37 in GEE. Let's see. Yeah, for example, this is one. Okay, this is the 37 north, and this is the right code. So if your study area is in this area, you just select this one, copy it, and paste it in the script here. For the folder, it will create a folder in your Google Drive and name it, for example, whatever the name that you want. I named it here as ABCDryBasin. And then any exported image will be saved in this folder. I made like 3 commands or 3 export, 3 types of exporting. Let's say I exported the index, which represent the NDVI. I exported the index with constant, which represent the EVI in the code here, as you can see. This is this one. And also I exported the land surface temperature, which is the ST band from the dataset mean. Okay, so this is the dataset mean, which is the reduced image of the dataset. And from that, I just want to select or to export the ST band, the surface temperature band, which is STB10. I named it as, for example, LST for January 2023. The scale is 30. The region is stable. The coordinate system is the same. And also the folder, for example, AGI. It's your choice. If you want to export it to the same folder, you just copy this one. You can copy the folder from here and just paste it down there. So it will export it immediately to this folder. I will hit run to see the results. So as you can see here, this one, the first one is the command the print command in line, here it is, in line 40. So this is the first print command. The second one is this one. Is this one. In line 55, dataset mean. And as you can see here, the name of this print is dataset. It contains 7 bands. And also, the first one contains 2 elements. The second one, because it is the mean of these values of these 2 elements, it will appear in one image. It is the mean image of that image collection. The third one is this one, which is line 75. And as you can see here, the name of that print is NDVI _1 2023, and it contains 1 band, which represents the NDVI band. We will, if you want to check that, you just hit this small arrow, and then you will find the NDVI here named here, sorry. And after that, if you want to go to the next one, for example, the EVI, for example, we will find it in line 87 here. So this is the print result of this command here, which represents the EVI image. Okay, for the exported images, we will find them in the tasks tab here. So this is the exported NDVI, which is this one. And this one is the exported EVI. And this one is the exported LST. If you want to download it, you hit the run next to that image. It will show you the properties that we added within the code. If you agree on them, then hit run, and it will start download, or let's say download or export it to your Google Drive, which is actually the Google Drive associated to the your Google Earth engine. So once it finishes, you can just hit this small arrow here in order to see its properties, and we will find here another button says open in Drive. Once it finished here, it will show another button to open it in Drive. So you will wait for a while until it complete the exporting. You will see a small check here, means that the image has been exported to your Google Drive. So once you click on this small arrow, then you will find open in a Drive. Just hit it, and it will send you to your Google Drive account, to that folder, and you can see the image that we have exported here. You can download it and use it with any other software that you want. So this is the end of session 2. Thank you very much.